Hello friends, this is a channel called Gate for Free. That means on this channel you will be able to see content which will help you in understanding the basics of engineering subjects of mechanical engineering. The content on this channel will be helpful for you to clarify your basics of mechanical subjects, and the content will be such that it will be focused on solving problems. Specifically, the target exam for this channel will be GATE examinations, and all those students who are in their final year or who are pursuing engineering and have a aim of cracking GATE examinations will definitely be benefited from this YouTube channel. So in this in the course of time we will complete all the syllabus of GATE of all the subjects. And to start with, today we are going to start with the subject called strength of material. And without wasting any further time, let's start it. Our focus will be solving problems, but before solving problems we will first have a look at some basics, and then we will go on for solving problems. And okay, look at some basics, right? So in strength of material, our objective or aim is to do load analysis. Our aim is to do load analysis. Now, what is the meaning of load analysis? That means suppose there is an element, and on that element some forces are acting. Now, what is the effect of this load? This is nothing but load. What is the effect of this load on this element? That means how this element behaves when different types of loads are acting on this element is nothing but studied in this subject called strength of materials. Now, here, what the things that are known to us? The known things are the material that element is made up of, and also its dimensions. Now here the known things to us are these two, and we have to do load analysis. Now we know that these things are known uh, in the subject called machine design. Now in machine design we find out the material and the dimensions which is safe, which will keep our element safe during the working stage. But here in the strength of material subject, our aim is to do load analysis. Now to do load analysis, first of all we need some we need to first know about the different types of loads. Now, what are the different types of loads? Like suppose there is this element. Now, on this element, such types of load are acting which are pulling the element, or the load is along the axis. If the load is along the axis, then such type of load is called as axial load. Axial load. Now, suppose this is the element. Now this axial load can be tensile as well as compressive. If it is pulling, then it is tensile. If it is compressing, that is compressive. Now suppose this is my axis and load is perpendicular to this axis. Such type of load is called as shear load. Such type of load is called as shear load, perpendicular to the axis. Perpendicular to the axis. Now The third type of load is nothing but, suppose this is one shaft. Now now this plane in which this cross section is there, this plane is called as longitudinal plane, transverse plane, sorry, perpendicular to the axis, transverse plane. Now if suppose a torque is acting in this plane, transverse plane, then we call it as twisting load. Twisting load. Twisting load. Moving forward. Now again consider the same shaft, and the plane in which the axis of the shaft lies is called as longitudinal plane. Longitudinal plane. Now if in this longitudinal plane moment is acting, and such type of load is called as bending load. So now if we look at the types of load, then there is axial load, which can be tensile or compressive, and there is shear load, which is perpendicular to the axis, and the axial load is along the axis. Then we have seen that if in a transverse plane, if a moment is acting, then that is called as twisting load, and in the longitudinal plane, if moment is acting, then we call it as bending load. So in all we have seen four types of loads, and after knowing the types of loads, we will see the tools that we are going to use throughout this subject to solve different types of problems. So these three simple tools which we are going to use is, first one is equilibrium. This we are going to use quite often. In this equilibrium, what is the equations that we are going to use is summation of fx equal to 0, summation of fy equals to 0, and summation of moment about any point, let's say p equals to 0. So this is the first tool, equilibrium equations, that we are going to use to solve most of the problems. The second tool, if these equilibrium equations are not enough to solve a problem, then we will also use our second tool, that is compatibility. Compatibility. Actually, this is the equation that is imposed on our problem because of constraint. Because of constraint. For example, like this. Suppose there is a beam of length L, and if we increase its temperature by delta T, what will happen? Its length will increase by delta L. Its length will increase by delta L. But suppose if we fix this on other side, then we know that even if we increase its temperature or decrease its temperature, its length will remain the same. That means the delta L will be 0. Now this equation can be used for finding the reaction forces on both sides, and this equation, which is imposed by this constraint on the right hand side, by putting the fixed constraint on right hand side, we get this equation, and this equation is called as compatibility equations. If you didn't get compatibility, even now I'll give you another example. Now consider a beam. Now here weight W is acting at this point, a point load W is acting. Now because of this point load, this beam will deflect like this, correct? This beam will deflect like this. But suppose, and here the reactions are Rx, Ry, and moment. Now suppose they have told that on this beam there is a roller kept over here. This roller, this is a fixed support, sorry, a roller support is provided at this point. So now here three unknowns are there, and as well as now here fourth unknown will be there. So we have only three equations. We have only three equations, only three equilibrium equations, correct? So it will be impossible for us to find this extra reaction R. So in that case, what we will do is we'll use the compatibility equations. Now here there was some deflection delta, but here because of this roller, this deflection will be zero. So now here the extra constraint, extra equations that we will get from compatibility. That means whenever the equilibrium equations are not sufficient to find all the reactions, then compatibility comes to the rescue and helps us in finding that extra unknown. And now the third tool is nothing but the stress strain relation. Stress strain relation, that is, stress is equals to strain in modulus of elasticity into strain. So these are the three tools which will help us in solving most of the problems in strength of material. Now we'll move forward. The next topic point that we should understand is now elongation due to loading, axial loading. Elongation due to axial loading. Elongation due to axial loading. So now we know the basic equations, like stress is nothing but into strain, correct? Now I can write this equation like this. I can write strain into change in length upon original length and stress as load upon area. Now this the equation for change in length will become PL by AE. That means by using this equation we can find the change in length. Like for example, this is an element. On this element a load P is acting. This is the length, and it has a uniform cross-sectional area as A. Now the change in length, delta L, because of this load P, will be given by these equations. Please note that this equation can only be used when the load acting is constant, the area through cross-sectional area throughout the length is constant, and the whole element is made up of same material and having a constant elastic of modulus E. Now, what about the case when, now I'll write the equation here, delta L is equals to PL by AE. Now what to do when this load and area are changing? Simply we need to integrate it. Like see, we can use this equation as integration of sigma x dx upon E, sigma x dx upon E, or we can use like the integration of P dx upon AE. This is whole integration of AE. This is the two equations. That means we can use these equations when a load, area and elastic of modulus is constant, and if any one of these three varies, then we can go for these equations. For example, to understand this better, let's take an example. Suppose there is a uniformly varying diameter rod. Now here the diameter is d1 and here the diameter is d2, and a constant load P is acting on both sides. Here P. Now its initial length is given as L. We need to find here change in length, delta L. Now here as we can see that load is constant, so we already know the equation of delta L is PL by AE. Now here we know that when load is constant, area is constant, E is constant. Now here E is constant as this element is made up of the same material. Load we can see are constant, but area is varying here in this case, so we can't use these equations. We need to go for the other one, and that says integration of P dx by AE. So here P and E are constant, so we can take them out of the integral sign, so remaining is dx by A. Now to solve this, we need to find area in terms of x so that we can uh, solve this integral. So what we'll do is let's say that a1 is nothing but pi by 4 into d1 square, and a2 is nothing but pi by 4 d2 square. So we will consider any section xx. Let's say this is x equal to 0 and x at x distance. Let's consider a section xx, and here nothing but x equals to L. So now the area at this section xx, area of x is nothing but a1, that means this area, a1 plus, actually first of all we will find out dx, the diameter at this section xx, diameter at this section will be d1 plus d2 minus d1 divided by L into, so because of space constraint I'll write it again here. It says that the diameter at this section will be d1, as the diameter is varying linearly, so that's why I am comparing with the equation of line, that is mx plus c. Here c is nothing but d1, m is nothing but the slope means dy by dx, so dy means d2 minus d1, and dx is L minus 0, so this becomes slope, and x is nothing but distance. So this is nothing but the diameter at this section xx. So find out area will be nothing but pi by 4 into dx square, and now what we have to do here is let's say dx equals to d1 plus some k. Let's consider this as kx. So area of x is will be nothing but pi by 4 dx square. That means pi by 4 into d1 plus kx whole square. Now considering delta L will become P by E. Here what we said that P by E, and here A will become as 4 by pi 4 by pi integration of dx upon d1 plus kx whole square. Now we can integrate it easily, and after integrating what we'll get here is dl will get as p. Now we have to integrate it from 0 to L. After integrating and solving this, what we'll get is, we'll get as pi by 4 d1 d2 into e. This is what we are going to get. This is how the problem is solved, has to be solved when the any one of the three, that is P, A or E, if any one of the three is changing, then we can go for this formula and then solve it. Now we will see some basic problems regarding these topics, and we will see them in our next video. So thank you very much and have a good day.